First question, and the only thing that is not discussed on your blue sheet, but when you're working on that extra review, you certainly could make yourself some notes about it, is what is the domain of a rational function? Okay, the domain. This rational function is 1 minus 6x, it's equal to 1 minus 6x over x squared minus 14x plus 13. The domain is what numbers could be put in the place of x. And what do we have to be careful about when we're looking at a rational function? We want to make sure the denominator does not equal 0. That's what we need to remember. So what we do is we sort of break the rules. We say, okay, well, I'll take x squared minus 14x plus 13, and I'll see what does make it equal 0. So right now, I am finding out what will violate the rule. Well, this is a quadratic equation. So let's solve it by factoring. I need a minus and a minus, an x and an x. I need factors of 13 that add up to be 14. Well, you don't even have choices. It has to be 13 and 1, which means x is 13 or x is 1. I'm not done. As a matter of fact, I could not be further from the answer than I have written down here right now. Because the domain is, you don't have to write out everything they did in math lab. They had the set of all x's, blah, 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 blah. All you have to do is say x cannot equal 13, 1. Something that is critically important is this symbol. Don't have an equal to. Make sure it says x cannot be 13, x cannot be 1. Is that okay for domain? Your domain question will be very, very much like this, both on the extra review and on your test. Yes?
Why cannot equal that? That's the answer you got.
Okay, let's go back. If I take a look at this denominator, and although I didn't write it this way, I could have written it as 1, whoops, let me go to black ink. I could have written it as 1 minus 6x over, if this were in factored form, it would be x minus 13 and x minus 1. The reason I said x can't be those numbers, what if x is 13? I'd have 13 minus 13, which is 0, times who cares what else. If the denominator is 0, the expression is undefined. So I have to say, see, I broke the rule right here. When I said, let it equal 0, find out what will make it be 0, and then exclude those numbers. So once you find out what will make it be 0, exclude them. Okay? Problem number 2. 2 and 3 have the same instructions. All it says is to simplify the rational expression. And hopefully you remember that simplify is another word for reduce. So I'm supposed to reduce 6x minus 42 over 7x minus 49. Now, if you look at your blue sheet, and by the way, if you don't have any with you, those of you in class, I have extras up here. You can take one with you today. Under reducing, it says factor the numerator and denominator, divide out the common factor, if any. Okay, can I factor that numerator? Yes. Do you see a common factor of 6? So that's 6 times x minus 7. The denominator, common factor of 7, and it is 7 times x minus 7. Can you now reduce it? Yes. X minus 7 and x minus 7 are common factors, so that divides out. And I am left with 6/7. That's my answer, reduced to lowest terms. Your book calls it simplified. So in order to reduce or simplify, first you factor, and you hope that if there's a common factor, you see it. All right, let's look at the second one that is still about reducing. And it has x squared plus 13x plus 36 over x squared plus 18x plus 81. Now, in this review, I'm going to go pretty rapidly through the factoring without doing a lot of discussion about it. So the numerator is a trinomial. I'm going to get an x plus 4 and an x plus 9. The denominator is a trinomial, and maybe somebody recognizes that it is a perfect square trinomial, but if you didn't, it's okay. It's x plus 9 times x plus 9. So hopefully you have been working on these lessons and you are really getting good at factoring. Do you see common factors of x plus 9? So to simplify this or reduce it, I divide those out and I'm left with x plus 4 over x plus 9. Okay, that's your first three questions. Numbers 4 and 5 have the same instructions. They both say to multiply and simplify if possible. So if I make this a little bit larger, I have s squared minus r squared over s plus r times s over s squared minus sr. All right, if you look at your notes, the blue notes, for multiplication it says factor numerator and denominator of each fraction. You have potentially 4 things to factor. First numerator, what do you see? Difference of squares. And it will factor into s plus r times s minus r. Denominator of the first fraction, I don't believe there's anything we can do to that. So it is an s plus r. You can put it in parentheses if you want. Times, the numerator of the second fraction is simply an s. The denominator of the second fraction, what can I do with that to factor it? Common factor of s. S times s minus r. Because this is a multiplication problem, I use that silly little phrase of bow tie before you multiply. So what do you see that I can divide out? Okay, s plus r, s minus r, and the s's. So, very important, what's left? 1. Because although I'm lazy about it, when a factor divides out of the top and the bottom, you're leaving a 1 behind. So that's a product of 1s on top and a product of 1s on the bottom. It's 1. What do you think a common wrong answer is? 0. And that comes from using the phrase cancel out. So lots of times you won't hear teachers use cancel out because cancel usually means nothing left. And now I have 1s. Okay, the second multiplication problem is problem number 5. And it is 4z to the third over 5 times 35 over z squared. Those are all monomial factors. So I can just look at them and start seeing if there are any common factors. I imagine everybody sees the 5s. 5 goes into itself once, 5 goes into 35 7 times. What else do you see? Z's. There are 2 factors of z down here which divide out with 2 of the 3 factors up here, leaving 1 z up there. the numerator. I am left with 4 times z times 7, which is 28z. And what am I left with on the bottom? A 1. So I could write a 1, but nobody writes denominators of 1. 28z is what we would expect. So 5 is probably easier than 6. I'm sorry, 5 is easier than 4. All right, number 6. The instructions on number 6 tell you to divide and simplify if possible. So I'll write it larger. I have z squared plus 9z plus 14 over z squared plus 10z plus 16. This is divided by z squared plus 7z over z squared plus 12z plus 32. And now that I have it all written, I remember what it says about division, which is keep, change, flip. So keep z squared plus 9z plus 14 over z squared plus 10z plus 16. Change it to multiplication. Flip the second fraction, and it is z squared plus 12z plus 32 over z squared plus 7z. And certainly you can find ways that you don't have to do all of that writing. All right. Now, it's a multiplication problem, and I need to factor everything. Numerator of the first fraction. I'm going to have z plus 2 times z plus 7. Like I said, I'm going to move through the factoring steps pretty quickly. Factors multiply to give me 14, but add to be 9. Next, for z squared plus 10z plus 16, I'm going to have z plus 2 and z plus 8. Times, numerator of the second fraction, z plus 4 times z plus 8. What about the denominator of the second fraction? Common factor of z? Z times z plus 7. So we remembered that division was keep, change, flip. In multiplication, we need to factor everything. Looking at the common factors, let's see. I have z plus 2's. I have a z plus 7. I have z plus 8. And I am left with z plus 4 over z. I know that you have thought more than once about the amount of factoring that you're required to do. Every problem, you've got to factor something, it seems like. Okay, so we've done we've done multiplication, we've done division. Problems 7 and 8 are addition, and 7 and 8 are the longer problems. Okay, I may need to add some space between these because I have 2 times 3x minus, 2 over 3x minus 21 plus x over x squared minus 49. If I were to look at the blue sheet about addition or subtraction, the first thing it says is get a least common denominator. How do I do that? Factor each denominator. Take one of every different kind of factor. So, how does 3x minus 21 factor? You have a common factor of 3. That's 3 times x minus 7, and you don't need that anymore. How does the second denominator factor? It's the difference of squares. So it's x plus 7 times x minus 7. So what's the common denominator? Yes, I need a 3, I need an x plus 7, and an x minus 7, and it doesn't matter what order you write those. One of every different kind of factor, and if anything is squared or cubed, you take the high power. Now it's time to compare. Compare the old to the new, and look for the change. What's the new factor? Do you see that the new factor is an x plus 7? So you're going to need to multiply the top by x plus 7. So it's 2 times x plus 7, and I'll distribute that in a minute. In the other fraction, compare the old to the new. What's the change? What's the new factor? 3. So multiply the top times 3, and you get 3x. And on the sheet, it actually says, build the new numerators. Compare the old denominator to the new denominator. Identify the change, the new factor. Multiply the old numerator by the change. Okay. Now I have 3 times x plus 7 times x minus 7 as a single denominator. And let's look at this part. I have 2 times x plus 7. That's 2x plus 14. I also have a 3x. Can I simplify this numerator? Do you see that you have a 2x and a 3x? So you have 5x plus 14 over 3 times x plus 7, x minus 7. And what's your final question to yourself? Can you reduce? Well, can you factor 5x plus 14? And you don't see one of those down there, so the problem's over. Addition is the long. This was the 7.4. Okay, we have another one. I have x minus 5 over x squared plus 15x plus 56 plus 3x plus 4 over x squared plus 3x minus 28. In order to get a common denominator, I'm going to need to factor these denominators. The first one, how about x plus 7 times x plus 8? The second one has a minus 28, so I know it's going to have one plus and one minus. I need an x and an x. Factors of 28 that have a difference of 3, 7 and 4. So what's my least common denominator going to be? Okay, although that came across as a couple of conflicting mumbles, I think I know that we need an x plus 7, we need an x plus 8, and we need an x minus 4, and you're welcome to have those in any order you want. You need one of every different kind of factor. It's time to build the new numerators. So I will compare the old to the new. What's the new or the change in the first one? X minus 4. So I need to multiply the top by x minus 4. So it's going to be x minus 4 times x minus 5. What am I going to do to multiply those in a minute? FOIL. Over on the right-hand side. What's the change? What's the new factor? X plus 8. So multiply it times the top. You have x plus 8 times 3x plus 4. And it certainly doesn't matter what order you write those. And again, we're going to use FOIL. I compared old to new. I saw that this was the new factor, multiplied it times the top. All right, one fraction, x plus 7 times x plus 8 times x minus 4. Okay, and you may want to listen or watch and then write down. I'm going to do this first product by FOIL, and I'm going to write down all 4 terms. The product of the first is x times x gives me x squared. The outer product is x times negative 5 or negative 5x. The inner product is negative 4 times x or negative 4x. The product of the last is negative times negative, which is plus 20. So this is the result of FOIL. And I know that a lot of you add the outers and inners in your head and would have written down minus 9x. That's great. All right, plus sign. FOIL for the next group. The product of the first, x times 3x gives me 3x squared. Outer product, x times 4 is 4x. Inner product, 8 times 3x is 24x. And finally, the product of the last, 8 times 4 is plus 32. All right, we need to combine some like terms, keeping the denominator of x plus 7 times x plus 8 times x minus 4. I have an x squared and a 3x squared, which gives me 4x squared. I have a minus 5x and a minus 4x for minus 9, plus 4, that gives me back to minus 5, plus 24, I think, is plus 19x, if I carried all that in my head right, which may not have happened. Then I have 20 and 32, which gives me 52. What are you supposed to consider before you call the problem done? Can you factor and reduce? I don't think I'd do that to you, but let's just look at it. It's only useful to factor if you're going to get one of these factors. Otherwise, there was no value to the factoring. Can you get an x plus 7? Well, does 7 go into 52? No, you can't get an x plus 7. Does 8 go into 52? No, so you can't get an x plus 8. 4 does go into 52, so I'm thinking, oh, what if x minus 4 is a factor? Well, look at the signs. The last sign is positive, the middle sign is positive. If I factored this, and I don't even know if it's factorable, but if I did, they would both be pluses. So can you get an x minus 4? No. Done. most probably that's what's going to happen to you on the other review and on the test. You're probably not going to be able to do anything with it. Those are the two long problems on the test. Nine and 10. These both say to solve the equation. That means that I'm in lesson 7.6, I believe. No, I'm in 7.5, okay? If I write all this down, and I'm going to leave a little spacing because I'm going to nestle in something in a minute. So this is for, well, if I can get black, this is, please, okay, I just had to be nice to it. 4 over y plus 5, and I'm going to leave a little space, minus 6 over y minus 5, leave a little space, equal sign, 8 over y squared minus 25. If you were to look at your notes, your blue notes for solving equations, it says find the LCD of all the denominators and multiply both sides of the equation by this value. I have an x plus 5, an x minus 5, and I have something that needs to be factored. This is the difference of squares. It factors into y plus 5 times y minus 5. So what is the LCD? Yes, y plus 5 times y minus 5. So I'm going to multiply each of the terms by that, and I'm going to sneak it in. Y plus 5 times y minus 5. Y plus 5 times y minus 5. And again, y plus 5 times y minus 5. When you multiply it by those, they are really over 1, even if you don't write it, which I usually don't. In the first term, what divides out? The y plus 5s, and you're left with 4 times y minus 5. In the second group, the y minus 5s divide out, and you're left with minus 6 times y plus 5, and an equal sign. In the last group, the y plus 5s divide out, the y minus 5s divide out, and you're left with 8. Looks like not too bad of a problem to simplify. Multiply by the 4, that gives me 4y minus 20. Distribute the negative 6, that's minus 6y minus 30 is equal to 8. Combining like terms, I have a 4y and a minus 6y, which gives me negative 2y. And I have a minus 20 and a minus 30, which gives me minus 50, and that equals 8. Add 50 to both sides. That gives me negative 2y is equal to 58. Divide by negative 2, and y is equal to, positive divided by negative is negative 29. Now, I didn't say anything at the beginning of the problem. I'm going to say it now, and you need to make sure that if you're doing the extra review and you're having those notes available, that you make some little note about check the domain. Okay? Now, the first denominator was a y plus 5. What can y not be if it's a y plus 5? Negative 5. The second denominator is y minus 5. What can y not be? Positive 5. And they're both here. So the domain was that x cannot be 5 or negative 5 in whatever order. Well, did you get one of those bad numbers? Then you're good. So if you completely forgot to do this, I would never know it. It wouldn't hurt. But it could be hurtful on number 10. So you always want to think about the domain when you're solving equations. All right, let's go to number 10. The original problem, and I'm going to space it out, is 1 over x plus 5, space, plus 2 over x plus 3, space, equal sign, negative 2 over x squared plus 8x plus 15. To find a common denominator, I need all the denominators factored. I take a moment to factor the last one, and you begin to see some patterns in these problems. This is an x plus 3 times an x plus 5, which just happen to be the other two denominators. All right, what is the common denominator? X plus 3 times x plus 5. So I will multiply x plus 3 times x plus 5 times each term. And that takes a little while to write that. First term, the x plus 5's divide out, and although I know you wouldn't really write this, it's 1 times x plus 3. I know that you don't need to write that 1. I'm just putting it there because if it had been a different number, you would need to have written it down. Plus, the x plus 3's divide out, and I have 2 times x plus 5. Equal sign. What divides out in the last one? X plus 3 and x plus 5, both of them divide out, and I'm left with a negative 2. Distributive property, well, the first one just stays x plus 3 plus 2 times x is 2x, 2 times 5 is 10, and that's equal to negative 2. I have like terms. I have an x and a 2x, which combine together to be 3x. I have a 2 and a 10, which combine together to be 13, and that's equal to negative 2. Subtract 13, 3x is negative 15, divide by 3, x is negative 5. And that's a problem. Because if we look at the original equation, the first denominator was x plus 5. What would cause x plus 5 to become 0? Negative 5. What would cause x plus 3 to become 0? Negative 3. And both of them are represented here. So the domain was that x cannot be negative 5 or negative 3. And that's just what we got. So the answer key is wrong. It has this x equals negative 5 listed. It should be scratched out because the answer is actually no solution. The same mistake exists on the extra review. It says the answer, I believe, is negative 10, something like that. And that is what we called yesterday an extraneous solution. Is that okay? 2 equations. Problem number 11 will be, not because it's hard, but because we're not going over it, we didn't go over it, will be extra credit. But if you were to look at the printed solutions, you'll see its solution. So let's move on to 12. Oh, good. Bigger. Even bigger. All right, it says, a painter can finish painting a house in 8 hours. Her assistant takes 10 hours to finish the same job. How long would it take for them to complete the job if they were working together? All right, I have an individual time of 8. I have an alone time of 10. And I have a question about together. So something that you might want to have on your extra review is that it is together over alone plus together over alone equals 1. And if, of course, there are 3 painters, there would be a third fraction. All right, for this particular problem, what is the first painter's alone time? 8. And the second painter's? 10. And what is their together time? We don't know, so we will call that unknown x. You now have an equation with fractions in it. What's the least common denominator? All right, now 2 is a common factor. 40 is the least common denominator. So I'm going to multiply 40 times this one, 40 times the second one, and don't forget to multiply 40 times the 1. 8 goes into itself once, 8 goes into 45 times. That gives me 5x plus 10 goes in there once, 10 goes in there 4 times. 4 times x is 4x. And that's equal to 40. 9x is 40 by combining those like terms. Divide by 9. And although in Math Lab you had to get the mixed number, I am not going to require the mixed number. You may just write it as 40 over 9. But if you want to write it as a mixed number, that's fine also. You could say 9 goes into 40 4 times, but that's 36. I'll have 4 left over. It is 4 4/9 hours. You don't have to do that, though. 40 over 9 will be just fine.
So just write it as a mixed number. What if it can be reduced?
You should reduce it as well. If I had gotten like 3 over 9, I would call it a third.
Okay.
Okay? Yes?
What if I take the common denominator to be 80?
Do what?
The common denominator 40. What if I take 80?
If this went in there evenly? No? I'm sorry.
That's not what I'm saying.
Okay.
Like the common denominator, the common factor
Yes, is 40.
is 40.
Uh-huh.
What if I take 80?
Oh, okay. I'm sorry. I misunderstood. If you had used 80 as the common denominator, you would have gotten the same answer. But what it would have looked like was 80 over 18. But 80 over 18 reduces to 40 over 9. So it's absolutely fine. If you use a bigger denominator, it just means you'll have to reduce somewhere in the problem. Because I did that yesterday, or almost did. Okay. 13. Whoops. All right, we have a pool problem. It says 1 pump can drain a pool in 9 minutes. That's either a very small pool or a very powerful pump, because it takes a little while. All right, 1 pump can drain it in 9 minutes. When a second pump is Also used. Now, what does also used mean? Is it alone or is it together? Together. It takes only 3 minutes. How long would it take the second pump to drain the pool if it were the only pump in use? And that would be alone. So, here's my scenario. Got 2 pumps. Pump number 1, do you know it's alone time? 9. Pump number 2, do you know it's alone time? No, that's X. Do you know the together time that they actually pumped? 3. What's the common denominator? 9x. So I will multiply 9x times each of these. In the first one, the 9's divide out, and I get 3x plus the second one, the x's divide out, and I get 27 equal sign, multiply 9x. I have x's on both sides. I'm going to subtract 3x. That gives me 27 is equal to 6x. Divide by 6. And x is equal to 27 over 6. Now, you can leave it improper. That'd be fine, but could that be reduced? Do 27 and 6 have a common factor? Yes, 3. 3 goes in there 9 times, and 3 goes in there 2 times. So if you want to leave it improper, 9 over 2 would be the form. If you divide it out, you'd get 4.5. Last 2.
I have a question.
Yes.
How do you determine what answer you get for the denominator and which one? Some of the 9x for the denominator.
Okay.
And 3 for the.
You determine it by this statement right here. Your time together, which is always going to be the same, always sits on top. Your individual alone time always sits on bottom. So in problem 13, it said 1 pump can drain it in 9 minutes. That is implied to be alone, so there's a 9 on the bottom. When a second pump is also used, that implies together. It only takes 3 minutes, so both the tops are 3s. How long would it take the second pump to drain if it were the only pump? That's its alone time, and we don't know it. Okay?
That's the question mark.
Yes.
Okay.
Okay? So you would want to make sure that you have this little format written down somewhere. Okay, last 2 questions. The instructions say simplify. These come from today's lesson on complex fractions. Is this a type 1 or a type 2 problem? This is if you could read that, it says type 1. That's horrible. It is type 1 because it is a single fraction over a single fraction. So I'm going to do division. This is x plus 1 over 4 divided by 3x minus 1 over 8. Keep change flip. X plus 1 over 4 times 8 over 3x minus 1. Is there anything I can reduce? 4 goes into itself 1 time. 4 goes into 8 2 times. Anything else? No. X plus 1 can't be factored. 3x minus 1 can't be factored. That's going to leave us with 2 times x plus 1 over 3x minus 1. And you don't need to do that product. If you did, it would be okay, but you don't need to. Type 1, super easy, I hope. Okay, type 2, number 15. And they will be in this order on the test as well.
Are you gonna ask what type?
No. This is type 2 because it has a sum and or a difference. And by the way, this little mark in front of the 3, I have no idea what it is. I couldn't make it go away. It's not a 13. It's just a mark. So, since this is type 2, let me write it right here. It is 4 plus 2 over x over 3 plus 1/6. How do I simplify type 2 problems? LCD. I have an x, a 3, and a 6. What's the common denominator for x, 3, and 6? 6x. So I need 6x times the first one, 6x times that one, 6x there, and 6x there. I had an x, a 3, and a 6. What will they all go into? Well, I need at least a 6 for the 3 and the 6 to go into, and I also need an x, one of every different kind of factor. Okay, first little product, 6x times 4, 24x, plus, what do I do with this next one? The x's divide out, and I have 2 times 6, which is 12, over, next one, 3 goes in there once, 3 goes in there 2 times. I have 2 times x, which is 2x squared. And the last one, the 6's divide out, and I have plus x. Do you think I can factor and therefore reduce? Let's look at the top. What could I do up here? 12 is a common factor. It's 12 times 2x plus 1 over, what's the common factor down here? X, and it's x times 2x plus 1. Oh, that was nice. 2x plus 1, 2x plus 1 is the common factor. That leaves you with 12 over x.
Can you go back up on the
Yes,
slide
ma'am.
where yeah, that one right there. So it was 3, 2, and then. So what was the answer, 2x?
It was 2, are you talking about this one? 2 times that leftover x times that x gave me 2x squared.
Okay.
Okay, anything else? Okay, I will stop that.